Okay, so 7C is sketching problems using factorization. So factorization can lead us into the intercept form. So in which case we will use x-intercept form to sketch is when the quadratic is easy to factorize. Okay, when the quadratic is easy to factorize. Okay, when it's easy to factorize, I can see it directly from the equation, or like with one steps, I can know how to factorize it. Then we can use the factorized form to sketch the quadratic. Okay, just want to mention that. Okay, this form, I actually not write this like really good because this B and this C are not the same as this B and this C. So we better change it to x1 and x2. Okay, just make sure you know that those B and C are not the same. Okay, that value is not that value. Okay, the B and C is not the same. And then the x-intercept will be x1, 0 and x2, 0. The B and C are not the same value. I just changed, well, if you like, you can change it to D and E. Okay, change to another 2 letters to represent. I will just use x1 and x2 to represent that. Okay, so for example, I have y equals to 2x squared plus 2 plus 5x. For example, we have that. I can do y equals to 2x plus 1 and x plus 2. So that's a 2x squared plus 5x plus 2. So what I can see, the x-intercept will be negative 1/2, 0 and negative 2, 0. Well, if you really want to make it look the same, I need to take the 2 as a common factor, and I have that. Okay, so therefore I have -1/2 and -2 as my x-intercept. Remember when trying to sketch quadratic by turning point form, we sketch the turning point first, and then the x-intercept, and then we find the y-intercept, and then we find the x-intercept. So that's the order. Now if we want to sketch for by using the x-intercept form, we find x-intercept first, and then y-intercept, and the last one is the turning point. We still find those 3 special points, but we find in a reverse way. Okay, we're going x-intercept first, and then y-intercept, and then the turning point. Okay, we go that order. So let's have a look at the question. That's all the theory. Let's just directly jump to a question and have a look. So if we want to sketch that one, I want to factorize that. What's the factorized form for that? Sorry, x
minus 6 and x minus 2.
X minus 6 and x minus 2. That's correct. Okay, so 1 minus 2 minus 6 give you -2 plus -6, and which is -8, which works. Okay, I have this equation here. And what is the x-intercept?
0, 6, 0.
Yep, 2, 0, and 6, 0 for the x-intercept. Okay, 2, 0, and 6, 0. Let's label that. And as we know, there's a line of symmetry. Where is that line of symmetry?
4.
How do we calculate that for?
That will be on 2 points.
Yeah, average the 2 points. It must exist in the middle of those 2 points. Okay, that's where its symmetrical line is. Okay, these 2 points have the same height. Therefore, if the middle must be averaging those 2. So if we average that 2, 6 plus 2 over 2 is a 4. So the line of symmetry must be here. Okay, my next question is, where's the turning point? Where's the turning point?
Plus 4.
Plus 12 is the x-intercept. Okay, plus 12, like somewhere, let's say here, is the y-intercept, 0, 12. Where is the turning point? Just not exact. Where do you think it will exist on this graph? Okay.
You substitute in the x value to find out. So then you do a.
What x value you substitute?
Oh, because 2 plus 6 on 2 plus 4 is the x value of
Yep.
the turning point. So you find the y value by substituting the x value of the turning point into the vectorized equation.
Yep, that's correct. Georgina?
Around 12.
Around 12? Okay, so it will become negative here. If the turning point, like, think about the turning point will be, like, the graph is this shape. It must be below. And another thing is, it must exist on this line. Because what x equals to 4 is, that's the line of symmetry. And that line of symmetry, what is the line of symmetry? Is the x value of the turning point. Okay, is the x value of the turning point. So you average those two, you actually get the x value of the turning point. So 4 is the x coordinates of the turning point. So x equals to 4 is the x value of the turning point.
Y equals to minus 4.
Sorry, what is it?
Minus 4. Y equals minus 4.
Y equals minus 4 by substituting. Yep, Hilia, what do you just same? Okay. So y will be, you substitute 4. So it's 4 minus 6 times 4 minus 2. You can sub into the original one, but I think the factorized one will be easier to calculate. That's y equals to minus 4. So 4 minus 4, which is the point here, is the turning point. Okay, is the turning point. So the turning point must exist in the middle. And we also will have this point, which is 8, 12. Okay, because it's symmetrical, you have 0, 12, then you must have 8, 12. Just a little bit above here. Well, then we sketch the graph. Okay, that's the shape of the graph. Okay, we must label 2, 0, 6, 0, 4, negative 4, and 0, 12. Okay, and 0, 12. Alright, that's how we sketch this one. Okay, next one. X squared plus 9x minus 22. What is the factorized form? Yep.
Bracket x plus 12. Bracket x minus
11 and x minus 2. Okay, that's the factorized form. Okay, 22 can be 2 and 11. You need a positive 9, so we'll want a negative 2. Okay, that's a plus 9. Okay, where's the x-intercept? What do you think is the, yeah, Kalia? 2 and negative 11. Okay, good. Have 2, negative 11. Well, negative 11 will be a little bit far on the side. Okay, that's negative 11 and 2. We can see the y-intercept directly from the original graph, which will be 0, negative 22. Well, I will change the scale a little bit. Okay, this graph is quite weird. That's a 40, and let's make that a 20. That's a minus 20, and that's a minus 40. So I have 1, 2, 3, 4, 5. Each scale is 4. Okay, each scale is 4. So what I want to have is 0, negative 22. So it's about here. Okay, 0, negative 22. Because the value is too large, so I changed the y scale to fit. Okay. What is the middle? Like the middle line of symmetry? How do we find the middle? So that's the next thing you need to think about. You have negative 11 now. You have 2 now. Where is the middle in between negative 11 and 2? So you use the same way to calculate that. You're averaging them. Okay. How do we average them? Yes, Hilia? Which one plus which one? 11 or minus 11? You use 11 and plus 2 and then divide by 2? Well, you can use 11 to add 2 to find the total distance. Okay, what's the total distance from those 2 points? And then divide by 2, which is half distance. But it's not going to give you the exact coordinates what you need to sketch. So you need to find the midpoint. It's basically find the midpoint between the 2. So you add those 2 and divide by 2. Okay, you add those 2 and divide by 2. So use minus 11 and plus 2 and then divide by 2. That will exactly give you what is the coordinates, what is the middle coordinates. So that is negative 9 on 2. Okay, negative 9 on 2, which is negative 4.5. Very close. But like remember it's plus, okay, it's plus between the 2 x-intercept and you divide that by 2. It's averaging your x-intercepts. So minus 4.5. Let's say we just have a line here. That's our line of symmetry. And then we have, well, if we have a point at 0, 20, negative 22, I must have one at negative 9 on that side. So negative 9, negative 22 as well, because it's symmetrical about the line 9 on 2. So 4.5 units and then another 4.5 units, which is a 9 units. Okay, that's the x value of the turning point. That's the x value of the turning point. Let's look what is the y value for the turning point. So the y value will be negative 9 on 2 plus 11, negative 9 on 2 minus 2. Okay, that's what we will have. So we have 22 minus 9 over 2 and negative 9 minus 4 over 2. Y is 13 over 2 times negative 13 over 2. 13 over 2 and negative 13 over 2. And y is negative 169 over 2. over 4. We need to times them over 4. So this is negative 42.25. Okay, it's negative 42.25. So this coordinates is actually negative 9 on 2, negative 169 on 4 is this coordinates. That's the turning point. That's where's the turning point. It's exactly the same as how we find the turning point before, but just like more complex of the calculation. So negative 42.25, which is the point here. It's just a little bit below that point. So you have that point here. And now you want to sketch the graph. Okay, that is the shape of the graph. Again, 2 x-intercept, 1 y-intercept, 1 turning point. You must label that. Alright. Any questions so far for those 2 exercises? Okay, if not, let's have a look at the next 2. Okay, for this one, we have the half in the front, which is quite like there's a coefficient in front of x squared. So to make me easy to factorize, I can first take out the x like a half as a common factor. So I have minus 4x minus 12 here. And now it's easy for me to factorize. That's x minus 6 and x plus 2. That will give me minus 4 in the middle. I will have x-intercept at 6, 0 and minus 2, 0. And you have the y-intercept at 0, negative 6. Because it's easy to factorize, that's all what immediately I can have. Okay, immediately what I can have. Okay, 12, 1, 1, negative 6, and 2 give you a negative 12, and you need a negative 4. So you have things like that, x minus 6 and x plus 2. Where is the middle? Yep, Emma. 2, how do you find 2? Okay, you plus those 2. So that will also be the x turning point. So minus 2 plus 6 and then divide by 2, you have 2 here. So your turning point must be on this line. It must be on this line. That's x equals to 2. You have 0, 6 here. Then you must have 4, negative 6 here. Okay, symmetrical points. Then last thing is to find the y coordinates of the turning point, which equals, okay, do not forget your half. Okay, the half must be there. And you have x plus 2. So it's 2 plus 2 and 2 minus 6. Half times 4 times minus 4, and that's minus 8. So turning point will be 2 and minus 8. 2 and minus 8. Is this point here. Okay, that's the graph. Have 2 x-intercept, 1 y-intercept, and 1 y turning point. Okay, last one is a little bit special. Okay, last one is a little bit special. So y equals to, I'll take negative 5 as common factor first, minus 2x and then plus 1. And if you factorize that, that is a x minus 1 and x minus 1. So it's x minus 1 squared. That's the x minus 1 squared. Okay, x minus 1 and x minus 1. So how many x-intercept you have? Okay, what is that x-intercept? 1, 0. Okay, you have only one x-intercept. In this graph, there is only one x-intercept. What that represents, or anything special about that, or anything you can tell about this fact? It is the turning point. So you will just make a note here. If there is only one x-intercept, then it is also the turning point. If there's only one x-intercept, then that must be the turning point as well. Why? Let's have a look at that fold. Look at the bottom line. Y equals to minus 5 x minus 1 squared. If I put a plus 0 at the back, that's x minus h squared plus k. Okay, that's x minus h squared plus k as well. So you have 1, 0 as the turning point also. So what I will have is 1, 0 is the turning point, and it's also the x-intercept, which is here. And I know 0, negative 5 is here. And I have 2, negative 5 here. Because line of symmetry is on 1, x equals to 1. And very obviously this graph is a sad face shape, okay, negative shape. So you have, the graph looks like this. Okay, that's the shape of the graph. It is the turning point plus is also the turning point is also the x-intercept, and I know the y-intercept. I can find another point which is symmetrical about the line. By 3 points, I can sketch the graph. the general equation, I can directly tell about the y-intercept, which must be the constant, because all these x become 0, and you will have the constant at the back, which is -5, as the y-intercept. So general equation is very easy for me to find -5 as the y-intercept. Okay, just instant, I can tell -5 is the y-intercept. Alright, that's 4 graphs. We practice 4 graphs on how to sketch it by using the factorized form, which is the x-intercept form. Now I have typed 2 questions, which is asking us to determine the equation of a given graph. Do you remember we did one in the what I did? This page. Where's that question? Here. In page 3, we did one question like that, given us a graph and asked us to find the equation from that graph. And in this graph, we have the turning point. Okay, in this graph, we have the turning point. So we use the turning point form to find it. Okay, to find the equation. And now we have a different case, which we don't have a turning point. There's no turning point given. Okay, there's not a turning point given. So we'll use the x-intercept form. Let's put a note down here first. Anytime this is the type of question as find equation for quadratic. For quadratic graph. Okay, so the first type is given turning point and any other point. Just one turning point and one any other point, that's fine. We will start to write over equation as a x minus h squared plus k, where h and k is the turning point. H and k is the turning point. I emphasize that again, you must have the a in the front. Okay, you must have the a in the front. The a is the dilation. You must, by substituting another point to find that a, to see the dilation, there's no other ways you can directly see a. Okay, must by substituting a point and find a. Second, given, okay, I will write in red, 2x intercept. Well, if only gives 1, doesn't work. Okay, only 1 doesn't work. It must be 2x intercepts and any other point. You will start to write y equals to a x minus x1, x minus x2, where x1 and x2 is given. Okay, in this case, h and k is given. In this case, x1 and x2 is given. Number 3. Well, just 3 or more general points given, which not including the turning point, not including the 2x intercept. Well, if it's not satisfied with any of the above case, it will be case number 3. Okay, if it's not number 1, if it's not number 2, it will become number 3. So you need to have at least 3 points. And the equation we'll use is just the general form, ax squared plus bx plus c. By substituting the point, have simultaneous equations, and then solve for that. If y y-intercept given, C will be known directly. If you know the y-intercept already, then C must be the y-intercept. Okay, so that's the three cases what we can have by finding quadratic equations. Okay, first we check, do we have turning point? If we have turning point, that's the best case. We need the least information because we only need one turning point and one other point, any other points. If we don't have turning point, then we look at number 2. Do we have two x-intercepts? If we have two x-intercepts, which is good as well, I just need to find a value, which I need another point, and it's 3 points. Well, if none of those cases applied, I need to go number 3. Well, very unlucky, I just need to set up more simultaneous, 3 simultaneous equations and trying to solve for A, B, C values. Okay, that's what we're going to have. Then let's have a look at this question. Which case I can use? Which rule I can use? The second one, we have 2x-intercept. Okay, the 2x-intercept, I need to start with y equals to a, x minus x1, x minus x2. Where x1 equals to -1, x2 equals to 3. Because you know that x1 and x2 represent the intercept. Okay, so the 2-intercept is -1 and 3. So we have -1 and 3 for both of them. So y equals to a, x plus 1, x minus 3. Do we know any other points on this graph? Because we need another point to work for a value. 0, minus 3. Okay, 0, minus 3, which is that point here. I have used this one, used that one, those two just gone. Okay, I need to find another point. Another point will be 0, -3. I will say when x equals to 0, y equals to -3, I will do substitution. -3 equals to a, 1 minus 3, minus 3 equals to minus 3a, a equals to 1. Okay, a just equals to 1 in this case. But not every time a will be 1. Okay, a will be a half, a will be 2, a will be any number depending on what you have solved out. So you make the conclusion x plus 1 and x minus 3 will be the solution. But a must be calculated. Okay, calculated first. We calculate a and we say a is 1. Then we make the conclusion. We can't just directly write our answer like that without calculating a. Okay, a must be found through calculations. Okay, must be found through calculations. So a is 1 and we have this equation y equals to x plus 1 and x minus 3. Okay, that's how we find equations when given us the graph. Okay, given us the graph. Alright, so that's what I'm going to teach for today. That's the type 2, how to sketch quadratic by using factorized method. Okay, by looking at the x-intercept form. We find the x-intercept first and then we find the turning point and then we complete the shape of the graph. It's a reverse order compared to the turning point form. Just do some exercise and tomorrow we will do the next page. Okay, tomorrow we'll do, not next page, which is this page, page 9, 7E. Okay, tomorrow we'll do 7E.